All right, so today we're going to be going through 2.1 notes. Now I'm going to kind of go quickly through these notes, but remember this is a video, so you can stop it, pause it, go back, rewatch. I'll kind of jump around. I'll tell you to pause at certain points to try problems before I reveal the answers. Remember, take these notes, maybe make a note of any questions you have for me that we can go over next class before we have our graded assignment. All right, so here I am in our packet. I'm on the first page. We're talking about rate of change, linear equations. All of this should be a review from Algebra 1. That's why it's a video. The first thing that we're going to talk about is constant rate of change here. So this idea of constant just means the same, right? We're changing by the same amount. So if I look at this chart here, whenever I see charts like this, it's always good to remind ourselves that x comes first, then y. I'm going to look at my chart here and see that every time I'm going up by 12. Okay, you can use your calculator to find that, but that change is constant. I cannot make that decision, though, yet that overall the rate of change is constant, because I also have to look at my x column. So I'll notice here I'm going up by 50 each time. So if we're thinking about change, we always use the symbol of a little triangle to represent change. Okay, so change in y is going to represent 12. And rate of change, right, we're doing something per something, miles per hour. Here we're doing We're doing fees per mile. Okay, remember our fee, our y always comes first, so fee per mile. So I've got 12 over my change in x is 50. And that's the same. Okay, so yes, my rate of change is constant. And then this fraction that I've created is my specific rate of change. I could simplify this. So 12 over 50, that could simplify to 6 over 25. So I would say here that I am changing by $6 every 25 miles. That's how that would work, okay? So when a data chart like this is constant, we call it linear, right? The rate of change is the same. You can think of it as a ratio of the rise of a graph to the run of a graph, right? That probably sounds familiar. The rate of change is also called, our magic word, slope. You probably can see that coming a mile away as we started that problem. So we're talking about slope. Slope is a rate of change. These are our three fractions that we use for slope. This fraction that I give you first, this is very helpful when I'm giving you points. This is the fraction we used above. It basically means the same thing, right? Change, that's all that is referring to. Rise over run, that's thinking about if we're looking at a graph, right? My y is always going up and down. That's why it's rise. And my x values are always going left to right, hence the reason we use the word run. Here are your steps to do it on a calculator. You can always find your equation using your calculator. If you have our graphing calculators at home, or I know phone calculators are getting pretty good, you can try these steps out on your own, but I'm not going to go over this in the video. You can ask me that later if you need. All right, on my next page, we're going to be talking about finding slope of a line, okay, when I'm given 2 points. So like I referred to earlier, we're going to use our fraction m equals y2 minus y1 over x2 minus x1. Okay, those are our, that's our formula that we use when given 2 points. It's really helpful if you were to look at the 2 points you're given and label them. So remember, x always comes first, and y. We label those with a 1 because that's my first point. Then I have x2 and y2. So now it's just a matter of plugging and chugging. So I'm going to come down here. I'm going to plug in my values. So I have a 5 minus 2 over 1 minus negative 3. Now, when we minus a negative, we know that we can turn that into a plus. So really, I have 3 over 4. I can't simplify that anymore, so I'm going to leave it. We never like to have decimals for slope. So for slope, we don't want decimals. Okay? So we always should leave it as a fraction. Now, why do we leave it as a fraction? Well, because it's helpful to graph. So if I come down here, there's two ways you could graph this. First thing I'm going to do is just graph using one of our points. So here I have, I'll use my pink point first. So if I take my pink point, I go -3 up 2. Okay, I would use my slope to go down to the next problem. So my slope is 3, 4. So in other words, rise over run. So here's my slope. Rise over run. So I start at my point that I made and I rise +3. 3. Then, 1, 2, 3. Then I'm going to run 4 directions, 4 spots. Now we always go in the right direction. Okay, it's always good to go in the right direction. That's what I like to say. Because it's positive, right? We're moving in the positive direction on the x-axis when we go this direction. So because I have a +4 there, I know that I'm going in the positive direction. Where I got to, that's where my next point goes. Once I have those 2 points, I can connect them. You also could have graphed this by graphing this point and then my green point and connecting the dots. All right, go ahead. I want you to pause the video and try number 2. All right, hopefully you had a chance to do number 2. Here's my answer for that problem. Okay, we got a slope of -6/5. I graphed it below. All right, let's look at number 4. So if we start number 4 here, okay, all I did was plug in my values to my formula so far. Now, when I go to solve this, I have 3 minus 0, which gives me 3. And then I have -4 minus -4. I know that becomes a plus, so I now have a 0. Now, if you were to punch this in your calculator, you would not get 0. Your calculator would say error. And that's because we are breaking one of the most important rules that we've talked about almost every chapter, is we can have no 0 in the denominator. Okay, so because I'm breaking this rule right now, this line is given an undefined slope. Okay, so my slope is undefined. Okay, so if my slope is undefined, what does that mean for me in my graph? Because slope tells me where to move, right? It tells me where to go. But if it's undefined, how am I supposed to know where to go? Well, let's start with our first point like we did with the last one. So I'm going to start with our blue one. So I'm going to go over 1, 2, 3, 4. There's my first point. Okay. Now, let's kind of do a little investigation here. Let's just plot our second point to see where that one ends up. So I go over -4 up 3. What do you notice about these 2 points? If I were to connect them, I'm just going to have a vertical line. So any undefined slope is a vertical line, straight up and down. Okay, I like to think of it in terms of if I'm skiing, here I am on my little ski poles. If I'm skiing and I go off this cliffside, I will become undefined at the bottom. I will be no more. Okay? Go off the vertical cliffside, you are undefined. Okay, here's our next little piece of notes you're going to want to copy down. Vooks Hoy, you might have heard it. Hoy Vooks, doesn't really matter. Okay, all you need to know is that when I have a vertical line up and down, I have an undefined slope, and the equation of my line is x equals a number. So there is no y in my equation at all. It's just an x. Okay, Hoy tells me horizontal. So if I have a horizontal line, I have a flat line. If you think about it, it's flat. If I were to sit on that with skis, I would be going nowhere, right? There's 0 slope for me to do anything. Okay, so that's why we have a 0 slope here. That equation is y equals a number. So again, no x, just a y. All right, concept summary. We look at graphs the way we read a book, left to right. So if I'm down here as a skier, I would be going up, right? This is positive. I'd be going in the positive direction. I'd be having to put forth positive energy to get myself up, right? I'm exerting energy. If I'm starting here, negative, I'm going down. Here, I'm not going anywhere. It's flat. So this is a slope of 0. And then undefined, if I go off this, I am undefined. Slope-intercept form, okay? This is our favorite equation. We love it so, so much. Okay, slope-intercept equation. Slope-intercept form tells me the two things that you would expect, right? It tells me a slope, and it tells me my y-intercept. Okay, that's why we call it slope-intercept form. Math people are not very creative. We could not come up with a better name. Okay, little trick to help you. M always represents slope. Think of it as move, right? M, slope, tells me where to move. Y is my B, or where I begin when I graph. So let's practice some of those things. So here I have some equations. We're just going to practice identifying our slope and y-intercept. So look at our first one, okay? My slope is always going to be my number with x. So my slope is -4. My y-intercept is always my number by itself. So I have a 3. Notice in this one, I always looked at the symbol in front of it. That's why I boxed in my negative, and that's why I included my plus. Okay, because those signs matter. Look at number 3. With number 3, I have a fraction in front of x, but that's still one number. That's not two numbers. My slope is 7/6. My y-intercept for this one is -2. Number 5, I don't even see an x, so don't fall for the trap of writing an 8 right there because we see it after our equal sign. Okay, there is no x there. No x at all. Remember, this is my y. Okay, my y equals a number. That's what this is, which tells me this is a horizontal line. So I've got to think horizontal line. What does that mean? That means I have a slope of 0. You could even write the number 0. And now my y-intercept. Well, my y-intercept is wherever this line is going to cross the y-axis. I'm telling you that y equals 8. If y equals 8, then I know somewhere it has to cross at the 8. So my y-intercept is 8. Go ahead, pause the video. I want you to try numbers 2, 4, and 6. All right, hopefully you had time to finish those 3. Here's our slope. Notice undefined. And notice for my y-intercept for number 6 is none. If you think about this graph right here, I'm going to be crossing at -1/2. If this is -1, let's just say this is -1/2. Here's my slope. Notice I don't cross anywhere on my x-axis. Okay, it'll never cross the y-axis. Oh, did I say x? It'll never cross the y-axis, so I don't have a y-intercept. Don't tell me 0 here. This is not 0. If it was 0, it would cross right here. Okay, so we write none. Two very different answers. All right, let's look at number 1 down here. Graph the equation of the line. Okay, so now I'm giving you the equation. We need to graph. First things first, let's identify my slope and y-intercept. So here's my slope, 2/5. Here's my y-intercept, or my b, of -1. Now remember what I said, my y-intercept is where we begin, right? It's my b value. So I'm going to come onto the y-axis and plot a point at -1. My slope now, remember, rise over run. So I'm going to go up 2, 3, 4, 5, over 5, plot a point. Connect your dots. Don't leave your dots not connected. Okay, mathematicians, we need to graph our points. One last thing too, let me get rid of my black line for a second. We can always plot another point by going in the opposite directions in both ways. So, for example, if this was a +2, we also know -2/-5 would simplify to 2/5, right? That's why this works. So if I were to utilize rise over run using my new fraction now, I'd be going down 2 to the left 5. So down 2, 1, 2, 3, 4, 5. Oh, that was a terrible last one. 1, 2, 3, 4, 5. Plot a point. So that's how we can plot the best line possible. We get 3 points on our graph. All right, moving on. Point slope form. Okay, so we've talked about slope intercept. Now we're going to talk about point slope form. Again, math people are not creative. We've got a slope in this form, and we've got a point. Okay, so those are the two pieces of information that this equation tells us. Obviously, here's our slopes, still using that letter M. And then here, my X and Y values from my point. Now, a common mistake that I see a lot of kids making is they don't realize which X and which Y to replace with a number. So just as a good reminder here, you're always going to be filling in these blanks when you write it. So my first Y and my first X are always going to stay as Y and X. The only place we're putting numbers are those blanks. So let's just try one of these together here. We have number 1, it says using the point 34 and slope -8. Okay, so here I have my two pieces of information. I have my M, -8, and here's my point. Here's an X1, Y1. Okay, so when I go to write my equation, I know that Y comes first minus my Y1 value, which is 4, equals my slope of -8, parenthesis X minus my X value of 3. Okay, and that's in point slope form, right? So that's it. That's technically done for that question. Now the next step is we're going to see some more math, because now it wants us to get it into slope-intercept form. So to get in slope-intercept form, remember, we got to get our Y by itself. Okay, we've got Y equals mx plus b. So I'm going to copy our problem down here. So to get this as Y by itself, I first need to get rid of parentheses. Remember, think back to PEMDAS. Okay, in PEMDAS, parentheses comes first. So I got to get rid of parentheses. So I'm going to distribute. So I have -8x plus 24. Okay, bring the rest down. And now I've got one last step to do. Let's get this 4 over to the other side. So I have Y equals -8x plus 28. And that is my slope-intercept form. Okay? All right. Number 2, when we look at number 2 here, I kind of started this one for us. If you look at number 2, the only difference is I'm only giving you 2 points. I haven't given you a slope for this one, which means my first step in this problem is going to be to find slope. Okay? So that's what I'm doing here, finding my slope. Once I find my slope, then I can pick a point. I picked this point, okay? You could have used my 2, 5. You just would have gotten a different equation at this point. Okay, you would have gotten a different equation there. However, our final equations in slope-intercept form should be the same. Okay? So go ahead and pause, and I want you to try B. So go ahead and try B. All right, so hopefully you had time to finish B. Here's our answer. Okay, again, first thing we did was we found slope, which was -1. Okay, then I picked a point. I chose my first point. Again, you could have done the other one. You just would have gotten a different point slope form. But our last equation should be the same. Okay, slope-intercept form. All right, let's look at our next page. So, next page, we're not going to be talking about parallel and perpendicular lines. So, parallel, remember, are like train tracks. They never cross. They're always going to have the same exact slope. Same sign, same numbers, everything. Which makes sense. These two lines right here, in order for them to never cross, have to be changing at the same exact rate of change. Perpendicular lines are opposite reciprocals. Okay, so their slopes are opposite reciprocals. What do we mean by that? Well, if one of my slopes is positive, the other needs to be negative. And if one of my slopes is 2/3, I flip it so that my denominator is now on in the numerator. Okay? Perpendicular lines have to have both opposite and reciprocal happening in order for it to be perpendicular. And again, perpendicular just means that they cross at a 90-degree angle. Okay, so let's try some of these. So look at example 1. It says determines if the lines below are parallel, perpendicular, or neither. Well, what holds the key to answering this question? Slope. Okay, that holds the key. So we need to find the slopes for my line 1 and my line 2. Okay? So let's just do line 1 first. So line 1, let's find its slope. So here's my 2 points for line 1. Okay? If I'm finding the slope for this one, I'm going to do 1 minus 2 over 3 plus 4. And I'm going to solve that. I get a negative 1 over 7. Okay? So that's slope for line 1. Let's just put that in a little thought bubble because that's not our answer. We're just thinking about what our slope would be. Line 2, let's calculate slope for that one. That one would be negative 2 minus 0 over 8 plus 4. And when I solve that, I can get negative 2 over 12. Now that one I need to simplify. So that'll be negative 1, 6. Let's put that one in a thought bubble. So now let's compare my two slopes here. I've got negative 1 over 7, negative 1 over 6. Well, I know they're not perpendicular because both are negative. One would have to be positive. And they're not parallel because I have a 7 in the denominator and a 6 in the denominator. So this one is actually a neither. Starting off strong. Didn't even see one that we just talked about. Okay, that would be neither parallel or perpendicular. Let's try number 2. Okay, so for number 2, line 1, let's calculate our slope here. Slope would be 0 minus 1 over 4 minus 2 equals negative 1 over 2. And again, I'm getting that from up top here. I've got my x1, y1, x2, y2. That's where I'm getting those numbers to find slope. Line 2, okay, we'd be solving this one by doing 10 minus 6 over 3 minus 1. And we'd be getting 4 over 2, which equals 2. Thought bubble. Now, right away, I can tell that these are not the same slopes. They're not parallel because one's a fraction, one's not. However, let me get rid of my cloud for a second. I know that 2 is technically over a 1. So if I were to compare my two slopes here, one's positive, one's negative. One has a 1 on the numerator and a 2 in the denominator. And one has a 2 in the numerator and a 1 in the denominator. So these are opposite reciprocals. Which tells me that this is perpendicular. All right, go ahead, try example 3 and 4. Okay, you can pause the video and I'll reveal my answers in a minute. All right, so hopefully you have time to finish those. If not, you can go back. My first one, we got another neither. We got 4 9ths and then we got negative 1. Not even close to each other to being the same, but also not opposite reciprocals, so it's a neither. Example 4, we got parallel. We got negative 1 for both of our slopes. All right, let's look at our next page here. Now, we're only going to do 2 of these examples on this page, but there's 4 total, so lots of practice for later. Look at example 1. It says, write an equation for a line parallel to y equals negative x plus 4 that contains the point negative 2, 5. Okay, so at this point, we're really going to combine everything we've talked about so far. Notice that I'm asking you to write an equation, meaning that is my final answer. Okay, my answer is not going to be a number. It's not going to be a point. It's not going to be a slope. It's going to be an equation. Okay. Now, when I ask you to write an equation and I don't specify, okay, so I'm not specifying what form of an equation. I really don't care. However, remember that slope-intercept form is the most helpful. Okay, that's the most helpful form of an equation. So that's probably going to be the best form of the equation to write your answer in. All right, now, in order to write an equation in slope-intercept form, what are the 2 things that I need? Well, I need a slope and I need a y-intercept. Okay, that's what I need to write this equation. I don't know my y-intercept at all, but I can find my slope. This line right here, parallel, tells me my slope. Because I want it to be parallel to this line, which means I want my slope to be the same. So my slope for my new equation is going to be negative 1. because right here it's a -1. Now my y-intercept, again, I don't know. However, I am given a point. So if I'm given a point and a slope, I'm ready to write an equation in point-slope form. Okay, so remember we've got x1, y1. So I've got y minus my y1 value, which is 5, equals my slope, which I know is -1, times x minus -2. Okay, so this is just what we did in point-slope form because I was given a point and a slope. So this is the form of the equation that I can write right now. So now let's just simplify. So I know this is going to turn into a plus, so I'm just going to change that now. I'm going to distribute my -1 in, so I have -x minus 2, y minus 5, bring that all down. Now I'm just going to add 5 to both sides. So my final equation is y equals -x plus 3. That would be my equation. All right, let's look at example 2. Now, example 2 is slightly different. It says, write an equation for a line parallel to 6x minus 3y equals 9 that contains the point -5, -8. Well, if I look at this equation that I'm given right here, do I know my slope just by looking at this problem? No, I don't. This form of an equation is actually in standard form, which you probably recognize. Okay, and standard form is the worst, actually the worst, because it does not tell us anything. Okay, all it tells us is intercepts. So, here we are going to solve for y, right? I'm going to try to get this equation in slope-intercept form, because then I can tell my slope. So I'm trying to get y by itself. So I'm going to subtract 6x from both sides. So I have -3y equals -6x plus 9. Then I'm going to divide everything by -3. So my slope-intercept form of this equation is 2x minus 3. Okay? 2x minus 3. So this is my slope, right? So the slope for this line is 2, and I want it to be parallel, which means my new line, looks like lime. My new line is going to have a slope of 2 also. Okay, so I know my slope is 2. Here's my point that I'm going to use. So now let's do y minus -8 equals my slope, x minus -5. Okay, so again, that's just plugging into point-slope form. And now we solve. So I'm going to distribute. So I have 2x minus 10. I have y plus 8 over here. So now I'm going to minus 8 both sides. So my new equation is y equals 2x minus 8. Something went wrong. Hold on. Oh, this should be a plus. Sorry. This turns into a plus. So my y-intercept here should be a 2. Positive 2. There you go. That's better. Yep. 2x plus 2. Okay. All right, now the next two I'm actually not going to do in this video just for time purposes, but all the answers are in Schoology. So if you wanted to try this, you can go into quarter 3 folder under Unit 2, and you'll find answer keys for these notes, and you can find your answers for example 3 and 4. The last problem that I'm going to do with you today is one of our application problems. I want you to try the other one on your own and check Schoology again. Okay, but here I have our first application problem. It says a college purchased exercise equipment worth $12,000 for the new campus fitness center. The equipment has a useful life of 8 years. The salvage value at the end of 8 years is $2,000. Write a linear equation that describes the book value of the equipment each year. Okay, so when you read this problem, you have to ask yourself, am I given a rate of change? No. Okay. Am I getting a starting point? Yes, right? We are given a starting point. It's right in the beginning because they purchased an exercise equipment worth this much. So before using it, this is the worth, right? $12,000, meaning the starting point. Okay? And then the last piece of information they give us here is the value after 8 years. Okay? So in other words, they're giving us 2 moments in time. We have a starting time, and then we have a time later on at the end of its life, it seems, at 8. Okay? I want you to think about these in terms of our values, x and y. Right? It's always good to define our variables. Okay? So y is the dependent variable. So that's going to be our book value. Okay, that's the value of this equipment. And the x is going to be the year, right? Which makes sense. That's the independent variable. The year is going to impact the book value, or the book value depends on the year. So now knowing that, know our points, remember our x, y. So we can create 2 points to represent these 2 moments in time. So what I underlined in green, the starting point. Okay, well, what year is that? Well, that's year 0, right? That's where we're starting. And its value is 12,000. The salvage value at the end of 8 years, well, 8 is my x, is 2,000. So that's my value. So we've created 2 points. Now that we've created 2 points, we can find slope. Okay, so let's find our rate of change here. So my rate of change would be 12,000 minus 2,000 over 0 minus 8. So when I solve this, I'm getting 10,000 over 8, which simplifies, negative 8, sorry, which simplifies to negative 1,250. Okay? So we just found our m, right? That is my m. That's my slope. So if I'm starting my equation over here, I'm going to put negative. Let me use a different color, actually. I know I've used blue for the all slope, but. So that's my slope. So that's what goes with the x. Now this part's nice because I'm actually given my starting point in this problem, right? This is where it's at 0. So I'm just going to add 12,000 on to the end. Okay, that would be my starting point. All right. Now, number 2, I want you to try on your own, and then again, I want you to use the answer key on Schoology to check your work. I'll give you a hint with this one. You're going to follow the same steps that we did above. However, one of our points is not going to be our starting point. We're not going to be given our starting point in this one. So you're going to have to use point slope form first.